So now we have a truly interesting problem here because we cannot get away with just working our logic through the problem anymore. Of course, we use equilibrium logic, but just seeing the forces is not possible anymore because we have forces that are not symmetric in these cables, and therefore we have to set up our equilibrium equations. So what we have here is a box or a container with 10 pounds, and that is acting clearly vertically downwards. And then we have AB, AC, and AD with dimensions given. So let's just go ahead and write out our equations. And I start with my conditions. Sum of the forces in X is equal to 0. Sum of the forces in Y is equal to 0. And sum of the forces in Z is equal to 0. And my directions are positive as described here. And now I can get started. 0 is equal to, in the X direction, let's start with our AB. So it's negative AB, right? So minus AB. And what do I need now? I'm pulling in the 2 direction, if I'm not mistaken. Yeah, that's the X direction. So minus 2, of course, I need to calculate the length first. I forgot that. So what is the length here? So the length AB is equal to 2 squared plus 2 squared plus 1 squared. And that is equal to 8 plus 1, so that is equal to 3, right? So that is 3 feet long. And I believe that the other one is no different because we have 2 and 2 and 1 just in different dimensions, in different directions. So therefore that's also 3 feet. So 3 feet. And so my division is always divided by 3 for cables A, B, and AC. So now I can continue with my equilibrium equation. I divide it by 3. And for the X direction, I multiply it by 2. And notice the negative. That's important here, right? Now for AC, it's also negative. AC, and again, it's also 3 feet long, but now it's 2, but it's a different 2. So maybe I actually color code this for your understanding. So this 2 would be this 2 here, whereas this 2 up here is actually this 2. And what else do we have in the X direction? We have AD. So my plus AD. Plus AD. Now in the Y direction, I think I can go ahead and put AB, AC, and there's no AD in it, but I of course have to divide it by 3. And now I am multiplying it in the Y direction by 1. For AB, that's actually positive. So that's this one. And again, let me color code it. So I'm looking at this guy here. And in the AC, it's negative. And AC actually is 2, right? So 2 over 3. And that's a different 2 now. So another color code here. So we're talking about this 2. And there's no other Y component anywhere, so I finished that equation. Now for the Z direction, I have plus AB times 2 divided by 3. And yet another color. So let me color code that as well. That's this one. And for AC, I divide it by 3 and multiply it by 1. And that one is our last number to identify. So I'm going to use gray here. I'm running almost out of colors. But I also need to include AD, which is non-existent. That is true for the one at the top as well. So plus minus nothing. However, I have to include the container, which was given to us with 10 pounds. And that is, of course, in the negative direction, minus 10 pounds. And now I have completely written out my equilibrium equations that now I can solve. That's definitely not my job here to teach you how to solve 3 equations with 3 unknowns. You can choose whichever method you want to. I will say that some students prefer the matrix method. So what would that look like? So minus 2/3 minus 2/3 plus 1. And then we have plus 1/3 minus 2/3 plus 0. And we have plus 2/3 plus 1/3 plus 0. And that would be the matrix, which you have to invert, of course. 0, 0, 10. And keep in mind that we're talking about AB here, AC, and AD. And if you solve this, you can find AB, AC, and AD, but I will not give you the answer right now. This is your job to complete this problem, to see if you are well prepared for these type of problems, because they will end up on your exam. And you definitely need to be able to solve these under time pressure. But I believe this concludes the problem and concludes our understanding of equilibrium in 3D. And we are now well prepared for our homework and upcoming quizzes and tests. So let's move on to our concluding page at the end of this lecture.